Chebyshev's theorem gives you an approximation of what percent of the data values will be within k standard deviations of the mean. So the proportion of values, so I'm talking about the percentage there, from a data set that will fall within k standard deviations of the mean will be at least 1 minus 1 over k squared. So that tells you 1 minus 1 over k squared, if you multiply that by 100, that's the percent of the data values that will be within k standard deviations. K stands for the number of standard deviations. If I choose 2 standard deviations, then I would expect 1 minus 1 over 2 squared, which is 4, and 1 minus 1/4 is 3/4, which is 0.75. So I can expect 75% of my data set to lie within 2 standard deviations of the mean. Now I'm going to draw a little picture here. Now with Chebyshev, you do not have to have mound-shaped data, even though that's the kind of data curve I'm drawing here. So if this is the mean, within 2 standard deviations on both sides of the mean, I can expect to have 75% of my data. Once again, this is mound-shaped data, and you do not have to have mound-shaped data with Chebyshev. If I had 3 standard deviations, that would be 1 minus 1/9, which is 8/9, which is 0.8889. So about 89% of my 8889. So that's 88.89% of my data points will lie within 3 standard deviations. So I've drawn a diagram here, picture here, and this is not mound-shaped. You know, it's not mound-shaped. It's not normal data. But what I can say here, within 2 standard deviations, so from here to here, and from here to here, I can expect to have at least 75% of my data points. And then within 3 standard deviations, which is between here and here, I can expect to have 89% of my data values. K does not have to be an integer, by the way. All right, let's look at the next example. Within how many standard deviations can you expect to have 75%? 2. The mean price of houses in a certain neighborhood is 50,000 and the standard deviation is 10,000. Find the price range for which at least 75% of the houses will sell. So let's go back and look. So mu plus or minus 2 standard deviations. My mean is 50,000 plus or minus 2 times standard deviation of 10,000. That's 50,000 plus or minus 20,000. So that gives me 2 values. 50,000 minus 20,000 is 30,000. 50,000 plus 20,000 is 70,000. So between 30,000 and 70,000, you can expect to have 75% of your houses. Okay, look at number 2. A survey of local companies found that the mean amount of travel allowance for couriers was 25 cents. That's the mean. I'm going to draw a picture. Now, once again, I do not know its mound shape, but just for illustration purposes, I'm going to draw as if it is. The mean is 0.25. Standard deviation was 0.02. Using Chebyshev's theorem, find the minimum percentage of data values that will fall between 20 and 30. So 20 is here, I'm just estimating, and 30 is here, and we're trying to figure out what percent that is between there and there. Well, let's first find the difference between those two. 0.30 minus 0.25 is 0.05, And let's divide that by the number of standard deviations. To find the number of standard deviations between these two values, 0.05 divided by 0.02 gave me 2.5. Well, that's K. It's number of standard deviations. So now you do 1 minus 1 over K squared. This is going to give me at least this much will be within the range. So that's going to be 1 minus 1 over 2.5 squared. Use your calculator, and this gave me 0.84, or 84%. So at least 84% of the data values will fall between 0.20 and 0.30.